Hello friends, in this video we will see behavior of R, L and C at t greater than 0. Exactly how it really behaves, RL circuit, whether it is RC circuit, what happens when RLC circuit. It is very important to see their behavior for t greater than 0 from gate point of view. Let us begin with the behavior of R, L and C at t greater than 0. Let's start with the very first element, resistor. Let's say current flowing through this I and voltage across this is, let's say, VR, that is voltage drop across resistor. We know the fact that I voltage across resistor R and R can be related with Ohm's law. So I can say VR is equal to straight away I into R, and this is what we call as voltage equation, because this equation of course gives you voltage. So this is called as voltage equation. And if you want current, you can write VR upon R. So this is straight away current equation. You have to use these relations for t greater than 0. So what we are discussing right now for resistor, inductor and capacitor, it is valid only for t greater than 0. So remember these equations. I'm sure you actually know this Ohm's law. So VR is equal to I into R and I equal to VR by R are nothing new for you. Let's move to the inductor now. Assume inductor with current as I, and because of I there will be a voltage drop across L which is VL. And let me tell you about I naught. I naught is nothing but previous current which was previously flowing through the inductor. So I naught is your previous current here. We know the relation VL is equal to L into di by dt. This is called as voltage equation. Why it is called as voltage equation? Of course it is voltage equation because it gives you what? Voltage. So this is voltage equation. Now suppose if you want to calculate current, so what you need to do is, as you can see, if you want to calculate current, the current is in the form of derivative form. So to take that current out of the derivative, you need to integrate both the sides. So let us integrate both the sides. So now this becomes VL dt. This will become L into I because integration and derivative cancels each other. So I becomes 1 upon L integration VL dt. So as you can see, this gives you current equation. In this current equation, you have to modify something, or rather I would say you have to add something, and that's nothing but I naught. And from where this I naught has come, as you can see, the resultant current, as you can see, this is I and this is I naught. Both of them are flowing in same direction. It means you need to add them. So without fail, you have to add this I naught to current equation. So this is how the behavior of inductor for t greater than 0. It gives you two equations, voltage equation and current equation. You may have doubt why not something is added in voltage equation. So of course it is not needed, because suppose let's do the reverse engineering. Suppose you have current equation and you have to get voltage equation. What you really do? So you're going to take a derivative of this, which is d by dt. So what is going to happen with I? I is going to become di by dt equal to 1 upon L becomes constant. You know the fact that derivative and integration cancels each other. So this integration VL will only become VL. Whereas if you take derivative of I naught, you know the fact that I naught is a previous current and of course has to be constant. So that derivative results into 0. So ultimately by rearranging the term, you will get the same VL equation which is over here. And that's the reason why voltage equation does not get affected for previous current. So this is about inductor behavior for t greater than 0. Let's see for capacitor also. Assume capacitor through which current I is flowing. So it is getting charged to a new value, let's say Vc. Whereas assume that capacitor was initially charged to a previous value V naught. Please understand this V naught is nothing but previous voltage. And what is known for us in terms of capacitor is current equation. So current equation is a popular equation that is known to everyone, C into dVc by dt. Since it gives you current, Therefore, it is called as current equation. Now suppose if you want to have voltage equation, as you can see, your voltage is in the form of derivative. To get that voltage out, you need to integrate on both the sides. So integrating on both the sides, you will get integration of I dt, which is equal to C into, as integration and derivative cancels each other, it becomes simply Vc, or you can write now Vc is equal to 1 upon C integration I dt. This is what your voltage equation is. But as you can see on the capacitor, there are not one but two voltages are there. I mean Vc and V0. Both of them are having same polarity. So the real voltage equation will be true only if you add V0 here. So what is V0? Of course it is previous voltage. So these are the behaviors of RLC for t greater than 0. Now we will move our discussion further for RL and RC circuits. See, your types of circuits are like this: RL circuit, RC circuit, and LC or RLC circuit. I'll categorize them into same. When it comes to LC and RLC circuit, they are called as second order circuits. So for second order circuits, we follow Laplace. And that's the reason why we are, since discussing for transient analysis, RLC circuit and LC circuits will not be a part of us for t greater than 0. See, whatever I am discussing, it is only for t greater than 0. So for t greater than 0, I won't be assuming for LC and RLC circuit. We'll analyze them separately in Laplace transformation. Why LC and RLC cannot be considered in transient analysis, that slowly we will discuss as our lecture progresses. So for RL circuit and RC circuit I am discussing. For t greater than 0 particularly, current I of t for t greater than 0. Please understand, I am talking about both circuits, whether it is RL circuit or RC circuit. Current I of t for t greater than 0 have got a fixed equation which is given as ISS plus k into e to the power minus t by tau. I of t is nothing but current. Next, ISS stands for steady state. This is your steady state current. This k is nothing but constant, and tau is what we call as time constant. Similarly, V of t for t greater than 0, V of t for t greater than 0 can be written directly. V of t is simply VSS plus k into e to the power minus t by tau. Again, VSS is nothing but your steady state voltage, k is nothing but constant, and tau is again time constant. So whether it is RL circuit or RC circuit, when you have to deal with t greater than 0 interval, at that case I of t and V of t have got same equations. As you can see, I of t is equal to ISS plus k into e to the power minus t by tau, whereas V of t is equal to VSS plus k into e to the power minus t by tau. What is exactly meant by tau? Let's see. So tau stands for time constant. The unit is seconds. Time constant tells you how your circuit is slow or fast. More the time constant, slower the circuit, and lesser the time constant, it is faster the circuit. So tau actually shows you how your circuit is slow or fast to the process. So for RL circuit and for RC circuit, we define tau separately. In case of RC circuit, tau is simply R into C, unit is seconds, and for RL circuit, tau is equal to L by R. Again, the unit is seconds. So please don't forget, tau is nothing but time constant, and we have got two dedicated equations, V of t and I of t. V of t is simply given as VSS plus k into e to the power minus t by tau. This is valid for t greater than 0. And I of t, we have equation as ISS plus k into e to the power minus t by tau. This is for t greater than 0. And please remember, they are valid only for RL and RC circuit. They are valid only for RL and RC circuit. So you have to observe very carefully whether it is RL or RC circuit. And the second question, you have to ask it yourself, is it really asked for t greater than or equal to 0? It can be equal to 0 also. So you can make it modification. You can say either t greater than 0 or you can say t greater than or equal to 0. Same equations are valid. So just remember these all concepts. V of t, I of t concepts are very, very important. Tau concept is very, very important. It is L by R for RL circuit and R into C, that is for RC circuit. So I'm sure you have understood all these things. How to deal with RLC for t greater than 0. Also how to deal with RL circuit and RC circuit. In next video we will see actually numericals based on RL and RC circuits for t greater than 0. Thank you so much for watching this video.